Okay, we're going to talk about lesson 6.1, angles of polygons, and we're going to talk about the interior angles and the exterior angles of our polygon. One of the terms I would like you to know is what a diagonal is. A diagonal of a polygon is a segment that connects any two non-consecutive vertices. So consecutive means one right next to the another one. On a triangle, we don't have that. They're all kind of connected. But when we get to a quadrilateral, they've got an example of drawing a diagonal there. Our pentagon, we can see that we have, we can draw two of those in there. They have a couple examples. And then a hexagon. There, you can draw more diagonals than are what's shown, but those are just some examples of drawing diagonals. The polygon interior angles sum theorem. It says the sum of the interior angle measures of an n-sided convex polygon is n-2 times 180. So on the right, you've got a picture of a convex polygon. A concave one is where the angles are actually pushed into the figure. This is convex. For this particular one, it is a pentagon. And a pentagon has 5 sides. The interior angles are the ones that are inside the figure. And you can see that actually we have 5 interior angles, just the same as the number of sides. So we're going to make an example out of this one. Our formula for the sum of the interior angles, so not the measure of each one, but just how much they add up all together, is n-2 times 180. N is the number of sides, so in this case, this one has 5 sides. So I would replace 5 with, or n with 5. And then simplify 3 times 180, which is 540 degrees. So, and that's true for any pentagon. All pentagons have an interior angle sum of 540 degrees. In the example 1, find the interior angle sum of a polygon. It says find the sum of the measures of the interior angles, so sum again, we need that sum theorem, of a convex heptagon. I don't actually have to draw the heptagon, I just have to know how many sides that has. And a heptagon has 7 sides. I also need my formula for the sum of the measures of the interior angles. So n-2 times 180 equals the sum of the interior angles. And so I can substitute 7 in, which that's equal to 5 times 180, and that's 900 degrees. So heptagons have an interior angle sum of 900 degrees. Okay, how could I use that in some other situations? Problem B says find the measure of each interior angle of quadrilateral ABCD. We already have 2 of them. We have angle B and angle C. Those are right angles, so each of those are 90 degrees. But we don't know about A and D. It would be really nice if I knew how many degrees were in the whole thing, and then I could set up an equation. So I'm going to use our angle, our sum of our interior angles theorem again, n-2 times 180. I have a quadrilateral, so that means that n is going to equal 4 here. 4 minus 2 times 180 is 2 times 180, or 360 degrees. So the sum of a quadrilateral is 360 degrees, the interior angles. Just like a triangle is 180 degrees, quadrilateral is 360 degrees. And then I can make an equation with what I have. I have a angle D, which is x degrees. I have angle A, which is 3x degrees. I have angle B, which is 90, and C, which is also 90. And their sum should be 360 degrees. And then I can simplify that equation and solve for x. So that's going to be 4x plus 180 equals 360. 4x then would equal, when I subtract 180, would be 180. And then divide by 4, x is going to equal 45 degrees. Now that's not my answer, that's just what x equals, because it said find the measure of each interior angle. So I have to substitute that back in. I already know B and C is 90, but the measure of angle A, which is 3x degrees, would be 3 times 45. That's 135 degrees. So that's A. And then the measure of angle D, which is equal to x degrees, would have to then be 45 degrees. So now I know all 4 of my angles. So we talked about different kinds of polygons, convex polygons. A regular polygon is a concave polygon in which all the sides are congruent and all the angles are congruent. And so that's pretty important. We've got a regular polygon that all the angles are congruent when we're talking about the sum of the interior angles. Example 2, we've got a little picture there. It says the poles for a tent form the vertices of a regular hexagon. So we actually have a hexagon here, and it says the poles make a hexagon, and you can see they're holding up the tent. There's our hexagon. A hexagon has 6 sides. When the poles are properly positioned, what is the measure of the angle formed at a corner of the tent? So we just want one of these angles is. We can call that x. But we don't know what one of them is, but we can do the sum. So let's start with that. That's the formula that we have. We have 6 sides. So that's 4 times 180, which would be 720 degrees. Now, I'll back up here a little bit. Again, we need that 720, but that's not our answer because we want on only one angle. Well, we said that it has 6 sides, so it has 6 angles. And since it's a regular hexagon, each of those angles is the same. So if we took that 72 degrees and we divided it by 6, which is our 6 angles, that should give us how many degrees each angle is, which is 120 degrees for each angle. Example 3, find the number of sides given interior angle measures. So the measure of an interior angle of a regular polygon is 135. So that's one of the angles, one interior angle is 135 degrees. Find the number of sides in the polygon. So it's a regular polygon, which means all of the angles are the same. So if I knew how many angles it was, how many angles I had, I could just multiply that by 135, and that would be the sum of my angles. We want to find the number of the sides. So I'm going to go back to that theorem, that sum. I do not know how many sides I have. That's the thing I'm trying to find. So I can't fully replace anything with n, but I do know a little something about the sum of the interior angles, that it's 135 degrees times however many sides I do have. So that's going to allow me to set up an equation to solve. N minus 2 times 180 equals 135 n. And then I want to distribute the 180. What's 180 n minus 360 equals 135 n. And then I want to get my constants on one side and my variable terms on the other side. I'm actually going to bring the 135 over with the 180 and the 360 to the other side. So subtract 135 from 180, and that's going to be 45 n. And when you add 360 to the other side, you have 45 n equals 360. if you divide by n, or divide by 4, n equals 90 degrees. Or, I don't know why I put that. Let's back that up. You can go ahead and laugh now. 45n equals 360, not 4n. This is going to make a lot more sense. So when you divide by 45, you get n equals 8. And that's the number of sides. Okay, we talked about interior angles. Let's talk about our exterior angles real quick. An exterior angle is created by taking one side of your polygon and extending that out past the figure, and then making an angle with the side adjacent to it. So that would be an exterior angle. We've got a picture of an exterior angle down here, or several exterior angles in our box. You can see that we have a six-sided figure, that's a hexagon, and then we can create 6 angles, exterior angles, with that figure. And so those are our exterior angles there. It says the sum of the exterior angle measures of a convex polygon is 360 degrees. So it doesn't matter how many sides you have, the exterior angles will always add up to 360, which means that the measures of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 plus the measure of angle 5 plus the measure of angle 6 is going to be 360 degrees. So it doesn't matter how many exterior angles I have, how big my polygon is, it's always going to have a sum of 360. It's good to use that with example 4. It says find exterior angle measures of a polygon, and you can see that we have a polygon here. It actually has 5 sides, so it's a pentagon. And we have 5 exterior angles, but we don't know the measures of any of those. We have expressions for them, but we do know that the sum of the exterior angles is 360. So if I add all of those up, all those expressions, it will equal 360, and I'll be able to solve for x. So let's start with 2x minus 5 plus 3x plus 10 plus 6x minus 5 plus 5x plus 2x, and that's going to equal 360 degrees. So I'm going to go through, since it's all addition, I'm just going to combine like terms, add my x's. So 2x plus 3x is 5x, plus 6x is 11x, plus 5x is 16x, plus 2x is 18x. And then my constant terms, negative 5 plus 10 is 5, minus 5 is 0. So my constant terms, at least on the left side, cancel, and I'm left with 18x equals 360 degrees. And then you want to divide by 18. So x equals 20 degrees. Okay, last one here. It says find the measure of each exterior angle of a regular nonagon. So regular meaning that all of the angles are the same. That means all of the exterior angles are the same as well. And we have a nonagon, which has 9 sides. Well, we know that they're all the same and there are 9 of them. So I'm going to let x equal 1 exterior angle. And so if I have 9 of those, 9x should equal 360 degrees. That's how you set it up. And then I'm going to divide by 9. X is going to be 40 degrees. So each exterior angle is 40 degrees. Okay, that's it. You have an assignment, the Skills Practice 6-1, and we'll go over that and I'll collect it on Monday. Have a great weekend.